Okay, good morning everyone. Can you hear me? The sound is clear? Okay. Somebody please give Madam response whether the sound is clear or not. Just type over comment that I can see your comment. Okay. Here, so I'm going to present now. Okay. Zuri, apa yang you tulis elbow cough apa maksud dia? Madam tak faham. Okay. So, buat sekarang Madam nampak Natasha, Thor, Shawa, oh early gang, yes. Okay, Amira, Shafinas, Alia, Zuhozin, Rene, and Amirami. Okay, good morning. Okay, thank you, Thor. Sound clear. Okay, so Madam will present now. Okay, now on the stage with Madam is Farah Hanis. Okay, Shah, where are you? I'm not sure where are you. If you can't join, never mind. You just join the YouTube. You just click the YouTube link. So today we are going to discuss PAL pre-PSPM and the revision test 2. Okay, just a brief review because I know all of you already watched through the video. So now just a brief review and double check the marks. Here it's a very short class. Okay. Okay, now Madam will share screen. Okay, over here, okay. Okay, Shang, you need to connect your mic and cam before you can add them to the stream. So you have to connect your mic first. Okay, never mind. Shall you just join through YouTube? Okay, because while Madam present, I can't see you. Okay, so first we go for POW exercise. Okay, POW. Okay, this is POW week 17. Okay, first of all, right, the first question given that the concentration of an ammonium is 0.68 molar. So you should know, right, the 0.66 molar actually is the initial concentration. So the question asks the concentration of ammonium. You have to take note, ammonia is NH3, is weak base. And ammonium is the conjugate acid. It's different thing. This one with NH4+. If according to the definition of Bronsted-Lowry base, ammonia will accept proton, then form the conjugate acid in the solution. Once you satisfy the concentration of ammonium, right, okay, it will help you to find the pH of the solution because through the ice table you can get some hints. Kb value is given, so this is double confirm this is weak base because only weak acid and weak base have the Ka or Kb value. And C, explain qualitatively how the above buffer solution control its pH when a small amount of sodium hydroxide is added. So let's check the explanation later. Okay, now we go for the answer. Okay, as usual, step 1, you have to write down the equation. Okay, always remember this is weak base. So it needs to, according to Bronsted-Lowry base, it needs to accept proton to form the conjugate acid. Okay, so no confusion. Every time, as long as you can identify the acid and base, you can write down the correct equation. Take note, must write down the phase, aqueous, liquid, aqueous, aqueous. This is weak acid, weak base reaction. That's why it's reversible error. So just now 0.68 is the initial concentration, product nothing, and then we ignore the water because Ka, Kb, Kc, Kp, Ksp, whatever, we ignore solid and liquid. So you just put a dash over here. Yeah, put a dash over water, the column for the water. And then the negative X is due to the reactant, the coefficient is 1. And then the product positive, the coefficient is 1, 1. Okay, then at equilibrium, so just sum up the initial concentration and the change of the concentration. So step 2, okay, after ice table, then is write down the Kb expression. So for the Kb expression, always remember is the concentration of product is ammonium and hydroxide ion over the concentration of the reactant ammonia. Next, you substitute the value. So x times x over 0.68 minus x for the Kb expression. Okay, and then 10 to the power of negative 5. So you must remember if the Ka or Kb expressions equal or smaller than 10 to the power of negative 5, then we do the approximation method. So you write down since Kb is very small, 0.68 minus x is near to the initial concentration, which is 0.68. So you ignore the negative x minus x over here. So straight away, You just, okay, 0.66 times the Kb value, and then set the answer, you will get 3.5 times 10 to the power of negative 3. Must make the conclusion, X actually is the concentration of ammonium and the concentration of hydroxide, because both of them having the same value for the equilibrium state, means XX. So you can write down X equal to 3.5 times 10 to the power negative 3 equal to concentration of ammonium. So this is the concentration mass with unit capital M. At the same time, you also can write down actually is equal to the concentration of hydroxide as well. Why? Because when we calculate the pH, we just deal with pH or pOH. Okay, we are not looking at the ammonium actually. We are looking for the hydroxide. Okay, so once we know the concentration of hydroxide, right, we can negative log concentration of hydroxide equal to 2.46. Always remember, this is hydroxide ion. So you are dealing with pOH, not pH. So if you want to find the pH, you have to apply the formula pH plus pOH equal to 14. So in this case, pH equal to 14 minus pOH. So this is the answer. Okay, just a quick review. Now we proceed for the next. Okay, Farah, boleh ikut?
Boleh.
Very good. So Farah on the stage with madam, that's why she can give me the response. So anything, right, you can type over the comment, then Farah will tell madam. Thank you, Farah.
Okay. Okay.
Okay. So next. Okay, based on this question, when a strong acid is added over this reaction, most of you will give me this answer: hydroxide, ammonium, form ammonia, water. Yes, it's correct. Okay, you can explain the concentration of ammonium is decreased, ammonia is increased. But how about this one? According to Le Chatelier principle, the equilibrium position will shift to the right. How to determine to shift to the right? Okay, as a result, the pH of the solution not quite affected. No problem for you all to explain this part. But how to explain the Le Chatelier principle? Okay, when you explain about the Le Chatelier principle, you have to refer to this equation. Okay, the equation, not written here. Okay, I open a slide for you all, sorry. Okay, give me some time. This is very important to make yourself clear. Why is shifted to right? Okay. When we determine the direction of a buffer solution, we must always refer to the equation at equilibrium, meaning that you have to refer to this equation. That's why, while I explain this topic, right, I encourage you all write down these three statements. The first one, buffer solution at equilibrium. Next, the reaction that occur in the buffer solution for the weak base or weak acid is partially dissociate. For the salt or the conjugate acid or conjugate base is completely dissociate. If you write down these three equations, it will help you to answer the question related with explanation. Okay, for example, based on the question just now, okay, use the red one. Okay, just now the question is when strong base is added, hydroxide. Strong base is added, you check over here. Okay, this is weak base. High concentration over the weak base because it just partially dissociate. So it's meaning that still many solution, the ion of the solution is in NH3. Okay, only a small amount, a small part will change to the product ammonium. In this case, the conjugate acid, high concentration of ammonium. Okay, this is the conjugate acid because it completely dissociates. Okay, so the first question, when strong base is added, it will react with weak base or conjugate acid? The answer definitely is conjugate acid because this is a neutralization. Acid react with base react with acid like that. So when strong base is added, it will react with the conjugate acid. So this happens. So this is the equation that you need to answer over the question. So you explain If a small amount of strong base is added to the buffer solution, hydroxide ion will be neutralized by the ammonium ion and then form the conjugate acid means by the ammonium ion means NH3, NH4 plus to form the ammonia and water. Hence hydroxide consumed. So over here, okay, so small change in pH and the concentration of ammonium decrease. Okay, now we go back here. If you look at this buffer solution at equilibrium, the concentration of ammonium decreases. Okay, now you go back to chapter 6. Concentration, Le Chatelier principle. When the concentration of ammonium decreases, the system will shift to the left or right. Farah? Okay, left or right? Oh, Farah not sure. Okay, Farah not sure. Okay, so I check for those in Condi. See, can give me the response or not? I try. Madam, try to shift to the YouTube live chat. Okay. Yeah. Okay. Zuri, shift to the left or right. You can type over there. Okay. Shift to the left or right. Anyone? Okay. I can check the comment over here. Are you still with me?
Sorry madam, dia stuck.
Dia stuck. So maksudnya you tak stuck. Right. Okay. Kenapa? I nampak dah jawapan. Oh, thanks for your response, Shah, Zuri, Ento, Amira. Okay. Yes. Shift to the right. Very good. So this is the hints. Terima kasih Farah juga. Okay. So this is the way to identify the shifting of a buffer solution. Always refer to the equation at equilibrium. When concentration of ammonium decrease, because ammonium already react with the hydroxide. So the concentration of ammonium decrease. That's why the system will try to increase back the concentration of ammonium by shifting to the right to form more ammonium, the conjugate acid. Clear? Okay. So meaning that for this power question, right, I will encourage you all write down one more point over here to help you to understand the shifting part. Here. So you must write down this. Okay, for your answer, okay. When a small amount is added, okay, I will paste this equation over here. Okay, so reversible error, okay, from base, and then you must mention buffer solution at equilibrium. So for part C, this is the answer for C. Okay. C. So you must write down this equation first. So that can help you to why the system shift to the right. Okay, I think clear. Okay, buffer solution actually is simple, not difficult. Okay, reversible error. Okay, madam, fine. Irreversible error. Yes, this is the reversible error. This over here. So this is the reversible error. Okay. Okay, now we proceed for the next. What is the next? Okay. After explanation for buffer solution, then we go for the calculation part. So for calculation part, right, we need to use the Henderson-Hasselbalch equation. So calculate the pH of a buffer solution made by dissolving 0.2 mole of acetic acid. Mole is given for the acid, and mole for the conjugate base or the salt is given, and then this is the volume. When number of mole is given and the volume is given, meaning that we need to find the concentration. Okay, first step, sure is formula. Okay. Step 1, write down the formula. Yes, this is the formula in general. After that, you must write down the specific formula. Means you identify which one is the conjugate base, the CH3 COO negative. And CH3COH is the weak acid. Now you substitute. Always remember, is log concentration of the conjugate base over the weak acid. So 0.2 over 1 actually is equal to 1. That's why the pH is 4.7447. And then now you check for the number of mole, because the question will proceed when the strong acid is added. So over here, you need to find out the concentration again, because the volume is changed. Okay, based on this question, what is the volume? Okay, the volume over here is 500 ml. Okay, and then 10 ml of strong acid is added. Okay. Initially, the concentration of the buffer solution, right? Okay, for the acetic acid and then for the for the sodium acetate and for the acetic acid, right, is 0.2 over 1 means 0.2 molar. But now the volume is changed. Okay, so you need to find the initial number of mole. Okay, and then determine the limiting reactant to minus the number of mole according to the limiting reactant. Normally, it's the strong acid or strong base added. So you check. Yeah. So calculate the number of mole by using mv per thousand. So it's 0.01 mole for the acid. And then for the weak acid, okay, mv per thousand, okay, 500 change to liter. Always remember concentration must in liter. So the number of mole of the ethanol acid is 0.1. So the initial mole of each of the solution, because buffer solution got the conjugate base and the weak acid as well. And then this one is the limiting reactant. Okay, that's why minus 0.01 for the reactant side, minus 0.01 for the reactant side. Okay, missing one reversible error here. Okay, must right. Always remember reversible error, aqueous, aqueous, aqueous. So this is the new number of mole. This is the final number of final mole of this buffer solution. And then the volume is 0.5 plus 0.01. So the new or the final volume is 0.51 liter. So apply the formula mole over volume to find the new concentration for this question. So this is the new concentration. Okay, now after you satisfy the concentration of the conjugate base and the weak acid, then you can substitute. You get 4.6576. And then the question asks about the change. So you just use the first part minus the second part. So the difference is around 8.7 times 10 to the power of negative 2. That's why the answer, some of the book, right, will give you 0.1. Okay, it will round up become 0.1. Here.
Madam,
Yeah.
Syah
Tanya?
ada nak masuk tapi kena
Oh, okay.
madam kena.
Syawa. Okay. Nampak dah Syawa. Hai Syawa. Hai Syah. Boleh je, boleh je. Siapa nak masuk boleh tekan. Kalau tak silap maksimum 6 orang. Okay? Okay. Zu nak masuk ke tak? Hozin? Kiranish? Okay, you try. Here, madam can open here. Okay, Farah is on the stage, Shawa is on the stage, and then Shah is on the stage. Please say hi to your friends, Shah and Shawa. You can say hi to your friends. You can say hi.
Hi, madam.
Hey guys.
Hi. Okay. Most of you can hear their sound, right? Okay. This is just for fun. Okay. This is the way. You always see other people, right, live in YouTube. This is the way they broadcast like this. Senang je. Tapi dengan syarat line kena stabil lah. Kalau line tak stabil tak boleh. Okay. That's why petang nanti madam akan buat revision for chapter 1 by using YouTube live. Maybe I will pick some of you to help me on the stage. In case anything happen. Okay. Okay, later. Okay. Okay, now I want to one more thing. I didn't teach you all about the calculation of titration. I just shared the video. So now we proceed with the calculation part of titration dulu. Okay, this part is not included in your lecture notes because right, if you check the learning outcome, there is no calculation for titration. But based on previous PSPM past year question, they come out this kind of question. So that's why I need to teach you all a bit. Okay. So wait. Okay, SN base. Video. Where's my file? Okay. Nanti ada kelas bio ke tak? Selepas ni.
Ada?
Ada. Google Meet juga ke? Ataupun buat kerja? Oh, Google Meet lah. Jadi tak boleh overtake lah.
Google Meet.
Maksudnya 10:30 sekarang. Okey, kena pastikan habis cepat lah. Okey.
Okay.
Okay. So, madam kena habis. Okay, first. Okay, tengok ah. This is a term that you should know. Okay, tak boleh buka besar, sorry. Okay. So these are the terms you should know. What is titration, analyte, titrate, endpoint, equivalent point. I think should be no problem because you already do the practical test for 2 times. So you should know the definition already. But you have to take note. Titrate is on the inside the burette. So this part you know the concentration. And then analyte is the conical flux, which the concentration is unknown. Okay. Please take note, even though every time our experiment is based on the top, okay, inside the burette, and then the conical flux is the acid. But this is not fixed. The question might change. Okay, so you have to take note. If base is inside the inside the burette, okay, so the pH will getting increased. Okay, if according to the chart, the pH will getting increased. But if I change to base, I change to acid, right? The pH will getting decreased. So means like this. Okay, it's starting is the acid pH around, maybe it's strong one is start from 13 and then getting decreased, or the weak one is starting from 11. So you have to read the question carefully. Which solution is inside the burette? Okay, next. For the calculation part, normally the question will ask about before the addition of base or acid, half equivalent point, and final volume. Okay, Thor is doing this part for the passive presentation. So I think he is quite familiar already. Okay, while you study this question, right, you must know total volume. Okay, this is for the sodium hydroxide. Another one is the volume for the acid. Okay, so acid is inside the conical flux. So you have to take note, meaning that this solution is started with acid. So pH is the initial reading. Okay, so what is the concentration of this solution? For the acid solution is 0.1. That's why the first part, before the addition of sodium hydroxide, so we just take the pH equal to negative log H plus. Why is H plus? Because HCl completely dissociate and then form H plus and Cl negative. And the ratio is 1:1. That's why we can straight away take the concentration of HCl 0.1. Okay, madam ulang sekali lagi. Semasa kira pH ataupun pOH, kita tengok H plus ataupun hydroxide. Bukan tengok benda lain. pH tengok H plus. pOH tengok hydroxide. Please take note. Jangan tengok benda lain. Okay. Next, half equivalent point. Okay, for half equivalent point, right, you must refer to the equation. Okay, so that's why step 1 over here, I already write down the equation. The ratio is 1:1. Okay, the ratio is very important because you know MAVA over MBVB equal to A over B. So since the ratio is 1:1, meaning that the volume to achieve the endpoint, in this case, total volume is 25 ml of hydrochloric acid. So meaning that 25 ml hydrochloric acid and 25 ml of sodium hydroxide, it will reach the endpoint. That one is the equivalent point as well. So if the question asks about half equivalent point, 25 divided by 2, so it's 12.5 ml. So now the volume of sodium hydroxide is 12.5 ml and the volume of the HCl is 25. In this case, the total volume is changed. That's why you need to find the initial number of mole again. Okay, so initial concentration by using mv per thousand. Okay, the answer is 2.5 times 10 to the power of negative 3. If you're not familiar, write down over here. Never mind, you just write down 2.5 times 10 to the power of negative 3 over here. Again, find the limiting reactant, sodium hydroxide. So minus the mole of limiting reactant. So the remaining one is the concentration of HCl. HCl completely dissociate H plus Cl negative ion. That's why now the mole of the remaining, the mole that remain for this solution is 1.25 times 10 to the power of negative 3 cl, H plus. Volume change, 25 plus 12.5. Mass change to liter, mass change to liter. So this is the concentration of the pH at half equivalent point. Okay, if an equivalent point means completely react for the reaction between acid and base, okay, meaning that there is no more acid or no more base, so remain water. Okay, salt and water. So in this case, you just write down water dissociate become H plus hydroxide. So this one you have to refer to Kw, which is the equilibrium constant. Okay, at this point, right, the concentration of H plus and the concentration of hydroxide is equal. Okay, is 1 times 10 to the power of negative 7. So pH equal to 7. Okay, yeah? So pH equal to negative log H plus, so equal to 7. So the amount of acid and base present exactly neutralize one another. Okay, so the last part, okay, just now there are 30 ml of sodium hydroxide. After 25 ml react with the 25 ml of sodium hydroxide, it continue, meaning that there is another 5 ml extra. So over here, the remaining mole is 0.5 times 10 to the power of negative 3 mole of sodium hydroxide. So now you are dealing with POH because the remaining mole is sodium hydroxide. NaOH complete dissociate become Na plus and OH negative. So the OH negative, okay, is 0.5 times 10 to the power of negative 3 mole. So now the volume is 30 plus 25 divided by 1000 in liter. So this is the POH. But the question asks about pH. So you have to, using pH equal to 14 minus POH equal to 11.96, near to 12. Okay. After you answer all the question, right? Okay, before addition, don't forget there is another question over here. So during PSPM, please highlight all the word kata kerja. Okay, so that you won't miss out any question. Graph. Okay, so graph, like just now, the power, just now there is a question about power. I will continue. That's why I jump to here first. Okay, first, title. You must write down the title. Titration curve of 30 ml of 0.1 molar sodium hydroxide and 25 ml of 0.1 molar HCl. Next axis, y-axis is the pH. X-axis is the volume of sodium hydroxide added in ml. And then the point. Okay, starting 0 is 1. And then half equivalent point 1.5. Equivalent point is at 25 ml 7. And then at 30 ml, okay, is near to 12. Okay, you must label the equivalent point as well. pH equal to 7. While you connect, right, make sure there is a steep part over this area. Okay, so this is the titration curve for strong acid and strong base. Maybe some of you might ask me, Madam, how about the calculation for weak acid, strong base, or weak base, strong acid? Okay, last time, yes, we have this syllabus long time ago, zaman saya. Zaman saya, Madam kena kira. But for your batch, actually no calculation already. But based on past year, only strong acid, strong base is same. So I just teach you this part so that you won't confuse. Okay, now we go back to how, last question. Okay. For a titration between, okay, this is ethanol acid. So this is strong base, weak acid. That's why the question just asks you sketch the titration curve. Okay, so keyword sketch titration curve and then indicate the pH at equivalent point. Simple question, indicate, simple. Because it's strong base, weak acid. So the equivalent point sure larger than 7. Okay, so the equivalent point sure larger than 7. Okay, so we check the answer. Okay, yes, equivalent point larger than 7. So this is weak acid. That's why it started from around 3 or 4, pH 3 or 4, until pH 13. Okay, title axis, the point. And then I want to ask you a question. Why is 56.7? How do you know 56.7 ml of sodium hydroxide will achieve the equivalent point? How do you calculate for this part? Okay, for those who are on the stage, can you answer my question? How you get 56.7? Anyone?
MAVA over MBVB is equal to A over B.
Yeah, you are right. Okay. Okay, but before that, you have to check the coefficient as well. For this coefficient is 1 to 1. Okay, for this coefficient is 1 to 1. Very good. Thank you. Okay. before you answer the AVA, you must check. Okay, so okay, plus sodium hydroxide. Okay, your answer didn't write down the equation, but I encourage you all write down the equation. Anda tahu tiba-tiba dia bukan bagi 1 to 1. Okay, okay, so you get CH3COH. The ratio is 1 to 1. Please jot down, everybody. Yes, the ratio is 1 to 1. So this is the equation, and then you can check the ratio 1 to 1. Make sure write down the phase. This is the reaction between acid and base. That's why one-way arrow. Okay, settle for the power discussion. Now we have a quick view for the revision test 2 and the pre-PSPM. Before I proceed, any question? Okay.
No.
No question.
Okay, good. This is pre-PSPM. Pre-PSPM, there are 6 questions, and then the discussion, the pre-revision test, just 1 question, or just 3 questions. So this is the same thing. Okay, we go for pre-PSPM first because I opened the file already. Send the mail sitting PSPM is high, so meaning that tutuplah face-to-face exam. Okay, the first question is about concentration measurement. Okay, the second question is about the limiting reactant. Okay, for this set of question is quite simple because straightforward. Okay, for this question you don't need to assume because the okay, write down the formula and then substitute to success to find the mass of the solution because volume of the solution is given, density is given. That's why first step you can find the mass of the solution. So this is the mass of the solution. But the question asks about what? The question asks about percentage by mass. Okay, and then the mass of the solid copper sulfate is given as well. That's why no problem. So you just write out the formula. Percentage by mass equal to mass of solid. Make sure you write out correctly over mass of solution times 100%. Okay, so you get the answer. Okay, formula, substitution, final answer with unit. Ini prinsip kira untuk kimia. This is the principle, formula, substitution, final answer with correct unit. Over here actually also the same. Formula, substitution, final answer with correct unit. Okay, so question asks about molarity. So you must know what is the formula of molarity. Mole of solid over volume of solution. Solid, yes, you know already. Mole, you can find out, you know the mass. So you divided by the molar mass, you get the number of mole. Volume, yes, you know already. 820 mil. So what are you going to do? Must change to liter. Again, formula, substitution, final answer with unit, capital M, or mole per liter. Okay, so total 7 marks. Okay, next, limiting reactant. Based on this question, okay, plus, if the question didn't ask this part, you have to find the limiting as well. Okay, if the question didn't ask about B1, you have to find the limiting reactant as well. Unless the question given very clear. So for example, I have to open revision test because there is one question. So that we can compare. Okay, like this question. You don't need to find the limiting reactant because Based on the question, already give you the hints. Excess carbon monoxide. Okay, meaning that automatically iron oxide is the limiting reactant. Okay, boleh faham Okay, so this one, just find the limiting reactant, find the number of mole, and then according to equation 1 to 2, and then you calculate is 0.5322. Okay, many of you might be confused. Oh, yang mana limiting, yang mana leader, I'm confused dah. Always remember, apa yang diberi, what given by the question, here is the given. This is the mole given by the question. After you compare, okay, this is the mole needed. Asal itu ialah dari soalan. Okay, now you check. If I am using 0.221 mole of carbon monoxide that given by the question, how many mole of hydrogen is needed? 0.5322. So now you compare. Given 0.6 mole of hydrogen, needed 0.522, meaning that more than it. So it's enough. Bagi tu 0.6. Apa yang saya nak tu 0.5322 sahaja. Maksudnya ada lebih. So, hydrogen is the excess reactant. Please take note, during chapter 1, I already mentioned you must make answer. Since mole hydrogen needed, bracket what is the mole needed? 0.5322. Tulis okay, mole. Okay, lepas tu more than ke less than. Okay, kata kunci, more than ke less than. Okay, mole available yang given. Available sama dengan given 0.6. Siapa nak cakap? Okay, so 0.6. So hydrogen is the excess reactant. Automatically, carbon monoxide is the limiting reactant. Okay, after that, you keep on have to compare with the limiting reactant. Soalan yang seterusnya yang kira tu semua mesti guna limiting reactant. Ada orang confuse limiting reactant guna mole apa? Guna mole yang asal. Guna mole asal yang diberi untuk kiraan. So that's why 0.2661 compare. 0.2661, 0.2661. Okay, yang first question asks about product. So it's 1 to 1. So time molar mass, you get the answer. Grammar. The second question asks about excess. Excess. Given 0.6, needed 0.5322. So this is the excess number of mole. Hydrogen gas times 2, so this is the mass of the excess reactant. One more thing have to take note. Hydrogen, nitrogen, oxygen, chlorine, gas, all is 3 atom. Always remember times 2. 16 times 2, 14 times 2, 35.5 times 2. Okay, done for question 1. If you notice, right, question 2, the question keep on repeating the same thing. Before the part 1, right, ask you to calculate the frequency, energy, and then lambda wavelength or the energy level, okay? Or ask you to sketch the energy diagram. Part 2 should ask you about proton number is given. Ask you write out the electronic configuration, okay, for the electronic configuration of SPTF notation, orbital diagram, whether it's atom or ion, and then identify the valence electron, write the set of quantum number or draw the orbital. Okay, this is our question we're asking. That's why chapter 2 actually is easy to solve. But most important thing, you must know how to apply the formula for the calculation part. That's why, first, formula. Substitution. Final answer with unit. Always remember, for your unit must in meter, for the lambda must in meter. If the question given is in nanometer, you must convert to meter. So question given is what form? Nanometer. Okay. Let's study the question first. Balmer series. Balmer series is n equal to Shawa. Balmer series n equal to Shawa tak ada dah. Shawa ada. Shawa, are you here?
Oh, ada.
Balmer n equal to
N equals to 2.
yes. Ini point yang sangat penting. Kalau tak tahu n equal to 2 tak boleh jawab. Semua soalan tak boleh jawab dah. Okay, thank you Shawa. Of the emission spectrum of hydrogen atom contain a line with a wavelength mean. Okay, calculate frequency. Frequency Okay, frequency like just like this. It's not related with Balmer, but next, determine the electron transition associated with this line. This one you have to know. And Balmer is n equal to 2. Okay, so formula, substitution, final answer with unit, conclusion. Okay, check betul-betul formula 1 over lambda RH1 over N1 square minus N2 square and then N1 must larger than N2. Complete. Jangan lupa tulis N1 is larger than N2 for the lambda, for the wavelength 1 over lambda formula. Energy tak payah. Tapi 1 over lambda kena tulis. N1 is larger than N2. Substitute final answer with unit. And then because the question is asking about electron transition, so you must make the conclusion. Electron make a transition from higher energy. Just now is n equal to 2, right? Okay, and then after calculate, this one is n equal to 4. So from n equal to 2 to n equal to, from n equal to 4 to n equal to 2. Here, clear? Okay, next Balmer series under which region? Very simple, visible region. Always remember, only Balmer series can give you the color green, green, blue, and red. Okay, green, blue, and red color. Okay, total there are how many region that you have learned? Shah, berapa region? There are how many region you have learned for this topic? Shah, are you here? The answer is 3, yeah? Ultraviolet. Shah,
Yes, madam.
there are how many region you have learned for this chapter, this part?
3, madam.
3, so please take the 3.
Visible,
Correct?
ultraviolet, and one more. I didn't. I'm not sure.
Infrared.
Oh, yes.
Infrared, okay, so you must know
Okay,
Lyman is ultraviolet, Balmer is visible, the rest infrared. Okay, thank you.
Madam,
Now
I have a question.
can.
Madam, for the
Sure.
C constant, right?
Mm?
The value is 3 times 10 to the power of 8 or negative 8.
Okay, this one you have to check the least constant. Let's check the least constant. Least constant. Let me check through the book faster. Okay, you always have to check the least constant during exam. Don't memorize. Don't try to memorize. You ask me, I also have to check for double confirm. So everybody can take out your book and check what is the constant for the speed constant. Sometimes, right? I know if not mistaken, this negative. The answer is negative. Thank you, Shah.
Okay, madam.
Yeah, thank you, Shah. So how about the answer? Is it correct? Okay, let's press the calculator. 3 times 10 to the power of negative 8 over 486.4 times 10 to the power of negative 9. Really? Something macam tak betul je. Everybody, please press the calculator double confirm. I get 0. Oh, yeah, correct lah. 0.06167. Okay, correct. Wait. So what is your answer? Let's check. No, answer wrong. Yes, Hozin, yes, you are right. In the least constant is negative. Yes, okay. Lain macam sipu. Okay. Sorry Lain kat rumah tak stable sebenarnya. That's why nanti petang Madam akan pergi saya power 8. Okay. Never mind. You just double check. Okay. The answer. What is the 6.17 is correct. Just the kuasa. Okay. Just the power. Okay. Since you know the concept already, never mind. Okay. We can proceed. Okay. For next. Okay. Dor, show your answer. 6.17 times 10 to power. Hozin and Dor, show your answer over the comment. So let's your friend and check. Okay, very good. You detect something. Okay, good. Jangan terima je, kena tanya. Okay, question B. I have to ensure that I have to, okay. Calcium 1s2, 2s2, 2p6. Okay, this is the electronic configuration SPTF notation for calcium because given 20. So electronic configuration, no problem. Sets. Okay. For the valence electron in calcium atom, draw a shape orbital valence electron and then write orbital diagram calcium ion. Calcium ion orbital diagram, you remove 2. Okay, that's why this is the orbital diagram. No other answer because the question asks about orbital diagram. And then for the valence electron is 4s2, so that's why it's at 4s, label 4s. Okay, take note, just label one arrow is enough, x, y, z. Okay, and then this one, ha, ha, ha. For those who write down all, so sorry. Because the question one sets. So it's 4, 0, 0 positive half and 4, 0, 0 negative half. Comma, yes. Or no. You must write down n. Okay. Clear? Okay, question number 3 actually is simple. Just a step 1. Maybe you will start. Huh? 3a, explain why pH can form dative. For this one cannot. Maybe you start. When you answer the question, don't be nervous. Normally the question asks what you have learned. Okay, during class. So step 1, you need to try to form the Lewis structure. Once you successfully draw the Lewis structure, then you know why it can form dative form, but this one cannot. Because when you draw the Lewis structure, you will notice. Okay, this one I explained already during the P. Okay, follow 5 plus 3. Total equal to 8. Okay, I think you all watch my video already, so you know, okay, I just skip. And then you get lone pair, okay, hydrogen, hydrogen, hydrogen. Okay, but for boron, so sorry, there is no hydrogen. It's incomplete octet. There are only 6 valence electrons. How it can form dative form with H plus? Because H plus also no lone pair. That's why cannot form. But this one, yes, can donate the lone pair to the H plus. So that's why lone pair is the keywords. From phosphorus, can donate to MC orbital of H plus. Mention an MC orbital of H plus to form dative form. While boron, no lone pair. Okay. Question B, no problem. Must label dative bond. This is simple question. And then question C, you have to draw the Lewis structure. And then you will notice double bond for the chlorine and double bond for the oxygen. So that's why there are 2 choices between A and B. And then you notice the structure B, the formal charge for each atom is equal to 0. That's why the answer is B, more possible, lowest formal charge. Okay, and then according to the question above, you have to identify the polarity and shape. So this is the structure, then this is trigonal planar. Okay, even though only one mark is given for the shape or the AB3, you have to follow my step because we're not sure when you write the AB3 or when you write out the 3 bonding pair mark will be given. You just write out everything because it's just a simple answer. Okay, like the step I teach you in chapter 4. And then polarity also the same. Okay, we must label partially negative, partially positive, partially negative, partially negative. And then must mention oxygen is more negative than electronegative than chlorine, cannot cancel, arrange asymmetrically, mu not equal to 0, that's why polar molecule. If you ask me, right, among all these chapters, right, which chapter is the easiest one? Chapter 4. Okay, chapter 4 is the easiest one. Because just drawing and explanation, and then all the explanation and the drawing step is exactly the same. For about chapter 5, if you look at this question, you know, limiting reactant is zinc because excess hydrochloric acid. Okay, and then amount of zinc metal. Given here is the volume, pressure, this is P total, and then this is the pH2O steam. Okay, and then the keyword actually is hydrogen. All the information is related with hydrogen. Okay, and one more thing, temperature is given. So for sure, this question you need to apply Dalton law and ideal gas equation. Settle. Dalton law, ideal gas equation. And then the ideal gas is focused on hydrogen. All is about hydrogen. Here, I think not much to discuss for this part. After success, find the mole of hydrogen, stoichiometry compare. So that's why even the equation is given, you must double check whether is it balanced. Jika persamaan diberi, jangan excited. Semak sama ada persamaan dia seimbang ke tak. Okay. So once compare, you know the number of mole and then time molar mass, you get the answer. Always remember, must be correct unit as well. Okay, B. B, this question keep on doing because we have did a lot of questions during power exercise. Okay, you must know the relationship between intermolecular forces, boiling point, and vapor pressure. If the intermolecular forces is strong, you need more energy, means higher temperature, so the boiling point is high. Okay, this is very difficult to break, that's why the vapor pressure is low. Okay, and the reverse one, and vice versa, intermolecular forces weak, boiling point low, vapor pressure high. So check, the question asks about what? The question asks about increasing vapor pressure. Means from low, a high boiling point to low boiling point. So that's why this is the first one, followed by this one, and then the last one. So the lowest temperature is the highest vapor pressure. Means the intermolecular forces for ethana is the weakest one. So, okay. After you compare, right? Okay, this is the step one you must arrange correctly. No other answer. This is the only answer. You can, ethanol is the strongest, highest vapor pressure. Soalan boleh tanya vapor pressure, boleh tanya intermolecular forces, boleh tanya boiling point. Jadi jawab dengan berhati-hati. Susunan macam mana? Okay, so for this case, right, I will explain like this. Ethanol has dipole-dipole forces. Methanol and ethanol have hydrogen bonds. So this one you just follow. And then mention the strength of intermolecular forces of dipole-dipole forces. Sorry, you just mentioned dipole-dipole forces is weaker than hydrogen bond, or hydrogen bond is stronger than dipole-dipole forces. That's why the strength of the ethana is the weakest. Yeah, the strength of the ethana is the weakest compared to methanol and ethanol. And then why? Ethanol and methanol both have hydrogen bond. Why ethanol is higher? Okay, this one you have to mention about molecular size. Then molecular size over here is related with dipole-dipole forces. So now you mention ethanol has larger size compared to methanol. So it has stronger dipole-dipole forces compared to it has stronger dipole-dipole forces. Okay, settle. Madam ulang. First you mention ethana dipole-dipole forces. Methanol and ethanol has hydrogen bond. At the same time, it also has dipole-dipole because if you draw the structure, CH3 OH, this is methanol. So over here is hydrogen bond. Over here is the dipole-dipole forces. Okay, ethanol, CH3, CH2, OH. Okay, here is the hydrogen bond, here is the dipole-dipole. That's why the size of the ethanol is larger. That's why the dipole-dipole for the ethanol is stronger than the methanol. Yeah. Okay, C tak payah cakap. C simple question, compare atmosphere solid and crystalline solid. Farah nak tanya satu soalan. Madam nak tanya satu soalan. Crystalline solid. Okay, yang lain. There are how many type of pakai Internet Explorer ke tak? Google Chrome. Tanpa betul Aisyah. Oh, Farah is not here already. Okay, never mind. Total there are 4. Okay, there are 4 crystalline solid. You must know how to stick the 4. Okay, was there anything? I have to double check. Okay, now proceed. Last question. Last 2 questions. Question 5, no problem. Simple. Cassie is given. Ask you to find Cappy. And then this one, all the concentration is given. Please don't try to draw the ice table. Ice table just special for find the concentration of Kc, Kp. So in this case, actually, it's compare Kc and Qc. So this is the answer. So QC expression, substitute final answer with, okay, and then conclusion. Not a, next is about amount of CO2 increase. What happened? Okay, what happened? If increased pressure is an added steam, what happened to the CO and Kc? If we look at this question, increased pressure, ignore solid, so this is 1, this is 2. Increased pressure, the system should shift to the left. If the system shifts to the left, CO decrease, isn't it? Yes, CO decrease. Kc won't affect by these two factors. Kc only affected by temperature. Added more steam, okay, mean that the high concentration for steam, so the system will shift to the right. When shifted to the right, the concentration of CO increase. Yes. Okay, finally last. Okay, last question. Actually, this is simple question. You have to check the definition of Bronsted-Lowry base. Acid. What given the conjugate acid for the following base? Okay, means base lah. So kalau you nak conjugate acid dia, you tambah H plus lah because Bronsted-Lowry base accept proton. That's why it will become HCN. And then this one will become H2CO3. So this is the answer. And then question number B, no problem because the pH is given, ask you to find the concentration of hydroxide and hydronium ion. Okay, no problem. Okay, C, we just discussed already in tutorial. One is in pure water, another one is in 0.2 molar calcium chloride, which has the common ion. Must make the assumption, assumption is a must. So this assumption is referred to the molar solubility in pure water. This assumption Y is referred to the molar solubility of calcium sulfate in 0.2 molar calcium chloride. So step 1, ice stable, no problem. KSP expression, substitute to find the X. Okay, one point is missing. Sha, what is the point missing over here? Here also the same, one point is missing. Conclusion. Semua orang pastikan buat conclusion. Conclusion. So make the conclusion, the molar solubility of calcium sulfate in pure water is 0.0141 molar, and the molar solubility of calcium sulfate in 0.2 molar calcium chloride solution Y is 9.9505 times 10 to the power of -4. This is negative, that's why not accepted. Okay, so this is the conclusion. Confirm is lower. Okay, so in order to increase the concentration of calcium 2 plus, so the system shift to the left to reduce the not stability. Okay, please jot down. I think the pre-PSPM not much to discuss. Any question do you want to ask about the pre-revision test? This one. Ada soalan tak? Soalan yang mana you rasa confused? I rasa soalan 1, 2, 3 ni semua okay je. Have to take note. Ni for one set. Jelas. Shifts. I want to discuss this question. Ni wavelength tak payah, energy tak payah, theoretical U tak payah, balance equation no problem, define no problem. Define no problem. I want to discuss this one. Never mind, this one we'll discuss later. Okay, so I need to discuss this one. This one no problem. Okay. This one you have to explain as well. If you look at my question, I didn't explain, so you have to explain why this one does not obey Octet rules because it is expanded. Why expanded? More than 8 valence electron and it has the empty d orbital. Okay, so we discuss the last question. 2D. Proton number is given. Okay. Okay, the proton number is given, and then the question just one set, and then the highest energy. Then draw the shape of the orbiter. So you just need to give one answer, either one. And then over here you must, okay, 3s2, 3p2. You must draw the s orbiter and 2p or 3p orbiter number. Why? According to Hans' rule, okay, if there are 2 electrons for the p orbiter, you have to singly fill first, meaning that it occupies 2 orbiter of the 3p orbiter. Maksudnya dia sudah masuk ke 3p, 3px, 3py ataupun 3px, 3pz. Antara dua-dua mana saja. So that's why you need to choose any 2. You must draw 2p orbiter and 1 3s orbiter in order to score 3 marks. Okay, if you check the calculation over here, right? Actually, you no need to convert, no need to convert to nanometer because the question didn't ask about nanometer. So you just remain your answer like this. It's enough. Okay, settle. Okay, so that's all for today. Wait, Okay, so that's all for today. So okay, later I will conclusion. Wah, bandanya semua. Okay. Sekarang Madam akan masuk Google Meet sekejap untuk tapak markah anda. Jadi semua orang sila pastikan markah revision test 40%. Markah penuh 40. Tak payah convert. Pre-PSPM 80. Jadi sekarang pergi kira, nanti Madam panggil nama anda, terus beritahu Madam je. Sekian, terima kasih. Jumpa kat Google Meet sekejap. 1 jam live kita berjaya. Thank you. Tinggal 12 orang je. Siapa tak ada? Okay.